Hello, ladies and gentlemen, and welcome back. We're looking at question 2 in this video on our Galois paper. We started the 2013 Galois last video, and here's question 2. If you haven't given it a try, pause the video and try the question out. It's on screen, or you can click the first link in the description down below and get a copy of the whole paper just for yourself. A thick red candle and a thin green candle are each 100 centimeters tall. These two candles are lit at the same time. As the candles burn, their heights decrease at a constant but different rates. The red candle takes 600 minutes to burn completely, so 600 minutes over 100 centimeters, 6 minutes per centimeter, I'm guessing. The green candle takes 480 minutes to burn completely. So we've got 4 parts here, 2 light bulbs, 2 written. By how much will the height of the red candle have decreased 180 minutes after being lit? Okay, well, I could say something like the red rate is 600 minutes per 100 centimeters. So just, 6 minutes per centimeter. And we're asking for, so after 180 minutes, well, that's going to be 1 centimeter per 6 minutes. 180 divided by 6 is 30. So 30 centimeters have been lost. Do we want what the height that's left? How much will it have decreased? The height will have decreased. So it'll now be down to 70 centimeters, but the height will have decreased by 30 centimeters. There we go. And if we don't want to show our work, we don't have to. That's quite all right. It is a light bulb question. B, how many minutes after being lit will the green candle be 80 centimeters tall? All right, slightly different. I didn't say, I said red rate, but I didn't write it. Let's say green rate. 480 minutes per 100 centimeters. That's going to be 4.8 minutes. Do I want to write that as a fraction or decimal? I'll leave it as decimal for a moment. Okay, so to leave 80 centimeters means we need to burn 20 centimeters. So how long does it take to burn 20 centimeters? Well, 20 centimeters times the rate of burning, it'll be 20 times 48. So 20 times 4.8, that'll be 2 times 48, or 96 minutes, when all is said and done. Okay. So again, just need to put our final answer, but we did show our work in case we mistranscribed our answer or something like that. Now, C and D, we have to write full answers here. So C, how much taller will the red candle be than the green candle 60 minutes after they are lit? All right, well, I would probably say from A and B, we know the rates. If we didn't write them down, then we could certainly calculate them now. So we know the rates the candles burn. So after 60 minutes, per centimeters, we'll have 10 centimeters. And 60 minutes divided by 4.8 minutes per centimeter. So here's where we might have wanted a fraction. 60 divided by 4.8, just grabbing my calculator, is 12.5 centimeters. So the red candle is at 100 centimeters, but then we lost 10 centimeters, so it's at 90 centimeters. And the green candle is 100 centimeters minus 12.5 centimeters, so it's at 87.5, a difference of 2.5 centimeters. So we could, if you wanted to, you could say the red candle is 2.5 centimeters taller. That would be a fine way to end C part. Okay, and then D, how many minutes after being lit will the red candle be 7 centimeters taller than the green candle? Okay, I don't know how much time, so let's say let T equal the time in minutes. Okay, and we want how many minutes after being lit? Okay. So, red height is 100 centimeters minus the time it takes divided by 6 minutes over centimeters. I probably should have done 100 centimeters over 600 minutes, but I was not thinking clearly when I initially wrote these, but that's okay. So 100 minus T over 6 is what we've got here. The green height will be 100 centimeters, T minutes, and then 4.8 minutes per centimeter. So it'll be 100 minus 4.8. Let's actually figure out what 4.8 is as a fraction. So it's 24 out of 5. Okay, so the difference there is 7. So 7 centimeters is 100 minus T by 6 minus 100 minus 24 T by 5. The hundreds will cancel out. 24 T by 5 minus T by 6. Get a common denominator, so multiply top and bottom by 6 for the first one. So we'll get 144 T minus 5T all over 30. So that'll be 139T over 30, multiplied by 30 on both sides, 210 centimeters is 139. T, 210 over 139. I'm not liking these numbers. Is 139 divisible by 7 or something? It is not, and it's not divisible by 3 or 2 or 5. So that's how many minutes, I guess. It seems a little odd. I don't like that in terms of the calculation I did there. So I'm just going to double check it. Should be 24 over 5. So it should be 5 over 24. That might make the numbers nicer, because those, the 139, those are bad numbers. I would not expect those numbers. So it's good that it caught my eye. And then that makes the calculation so much easier. Because now I can make everything over 24. So 5T minus 4T over 24, multiply both sides by 24. So we'll have 7 times 24, or 168, because that's the number of hours in a week. And 5T minus 4T is just T, so there we go. So 168 minutes after lighting. The red will be 7 centimeters taller. Does this make sense? Well, what did we learn? After 60 minutes, it's about 2.5 centimeters. So if we lose 2.5 centimeters, or if the red candle gains 2.5 centimeters in height every 60 minutes, then, well, 60 times 3 would be 180, which is still a little bit more than 168, and 3 times 2.5 would be 7.5, which is just a little bit more than 5 centimeters. So, yeah, I buy it as an answer. I'm not going to dig too much into it. The numbers are making sense to me now. So we're all good. So that finishes up question number 2. Up next, we're going to take a look at question number 3. So if you'd like to join me for that, you're more than welcome to. Thank you guys so much for watching. I'll see you next time.